Now it is visible to everyone.
Yes. So I welcome you all to this webinar on the incidents of present which provide a solution to the problems of future. So the idea behind this is how come the incidents which are happening today provide us with a problem that we search for a solution through our researches, like today's pandemic of COVID provided a challenge for the scientists to develop a vaccine within a stipulated short interval of 1 year or 11 months, you can say. So these are the kind of problems that comes into practice, and the scientists are challenged to provide solutions to such problems, and this result in the development of new kind of technology, a new kind of mechanism is developed which will prove beneficial to all the streams of science in future. So the idea, similarly, there were some nuclear incidents which happened in Ukraine some years back. So we have the key speaker today, Dr. Ksenia Minakowa, who's from the National Technical University, Kharkiv, Ukraine. And she is a theoretical physicist studying in solid state physics. And she has got vast experience in science popularization. And she was secretary of the Hands on Science Congress, which was held in UK last year. She will be speaking on the incident of the Chernobyl, which happened about some years back, and how the incident changed the technological aspects, uh, uh, the way of thinking, and how come we can influence the students towards such kind of developing such kind of scientific temper. So she will be speaking on that. And our second speaker today is Dr. Anadi Sinha, who is a retired outstanding scientist designated by the Department of Atomic Energy, and he was also an associate director of the National Nuclear Power Corporation, and he has published more than 150 technical papers. Please, please mute yourself. So we start with Saraswati Vandana.
या शोभ वस्त्रावृता या वीणा वरदण्डमण्डितकरा या श्वेत या ब्रह्मा शंकर प्रभृति देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेष जाड्यापहा।
Now I will request my head of department, Professor Poonam Tandon, to welcome you all with the presidential address. Ma'am, you are now presenter.
Yeah, okay. So very good afternoon to all of you. And I don't know the time, what is time in Ukraine. Maybe it is not the evening, it is the afternoon.
It's this
Professor,
afternoon.
it's afternoon. What is the time there? 1 o'clock or something like that? No?
3
Three.
o'clock.
Okay. So very good afternoon to the other persons from the other side, or maybe some very good morning for some of you and very good evening for some of you. Maybe we have persons from some other continent also. I think Puneet, there are persons from other continent also. So
Yeah.
first of all, I welcome Professor Minakowa and Professor Sinha on behalf of Physics Department, Lucknow University, and on my own behalf. And you are joining us on a very special occasion. It's a very special occasion that the Lucknow University has completed its 100th year. Okay, so it is we are in the process, like we are doing the centenary celebration. Okay, on the completion of 100 years, and the Lucknow University was established in 1920, and the Department of Physics came into the picture in 1921. The official formalities were completed in 20. So basically, we are starting the celebration for this special year, and so we are very lucky to have two great scientists and researchers with us. And I'm also very much thankful to Dr. Punit Kumar for taking this initiative and starting our centenary year celebrations with such a nice event. See, even we had big plans for the celebration, but because of pandemic situation, we are doing most of the activities online now. Earlier, we are planning series and many more things, and we did some offline activities also during 19 to 25th of November. But as far as other activities are concerned, we are in the new normal. We know the new normal, and we are quite lucky that we are now familiar with the online or virtual world. So it is very easy to connect with this virtual technology with connect with the any part of the world. So it is blessing in disguise, and because of this pandemic situation, now we are more connected with the outside world, we can say easily. Suppose earlier we were planning an international seminar, we have to think about accommodation and many more things. It was very complicated. But now we can share science with each other and in a very simple way, just by clicking to a link, and we can connect with each other like this. Even during this pandemic, the physics department did a lot of activities. We organized many international seminars, national seminars, and many quizzes, all things. And all our teaching right now, most of the teaching theory classes are online only. And now slowly we are switching to the offline system also. And we started some practicals for the students for PG as well as for the UG. But exams and many more activities were online only. So even the pandemic was not able to stop us from doing our activities or like that. So once again, on behalf of physics department, I welcome physics department. Like is working in many areas. We are working on most of the activities are mostly confined to the material science. So different type of materials ranging from polymers to ceramics or liquid crystals or different type of materials, superconductors. But there are groups working with theoretical physics, plasma physics, and there are some groups which are working with quantum chemistry or laser physics. So, like there are some groups which are working with the renewable energy. So, physics we are working in different areas, and it is very nice initiative taken by Dr. Punit Kumar that we have two big orators or speakers with us, and I am very much sure that our students will be benefited by the presence of both of you. And thank you very much.
Sorry, ma'am, I was not. I forgot to introduce Dr. Sanjeev Srivastava from Indian Institute of Science, Bangalore.
Okay.
He is also present here, and he is the representative of iSTEM,
Okay.
the program of the government of India to provide technical resources to the academicians and the scientists. So
I have heard about Dr. Sanjeev Srivastava about iSTEM. I think you developed the e-portal and to connect the different facilities of this. See, I am in the Committee of National Education Policy, NEP 2020 of UP government. And somebody told you about that you took the initiative of connecting with the e-platform. For example, we have many facilities at different places, but we don't know where we can get what type of facilities or what type of expertise of that. Okay, and I think Dr. Sanjeev Srivastava, I know from that only, and we are planning similar thing for the state of UP. We are planning a e-portal in which all the researchers, all the teachers will give their scientific expertise as well as the facilities available with them. For example, near the Lucknow University, we have Birbal Sahani Botany Institute, but many of us don't know what facilities they have. Okay, or someone want to do some research or collaboration in a particular area. We don't know the expertise that where this person is available. So with this type of data bank, what you are doing, so maybe that is very, very useful. And I know you, it is very nice occasion to meet you and to see you. Thank you very much. And so you will also talk about iSTEM today?
Yeah.
Hmm?
Yes, ma'am. He will be speaking on ISTEM right now.
iSTEM. Maybe we would like to invite you separately also to know more about iSTEM. Apart from this series, we are very keen to know more about iSTEM, and we would like to have similar things in UP. With that. Thank you very much. Okay. I welcome you also on behalf of Physics Department and on my own behalf. Thank you very much.
Thank you, ma'am. Now I request Dr. Sanjeev Srivastava to just brief us about the ISTEM and how we can be benefited from it. Yes. Sir, voice is not coming clear. You are muted.
Now it's okay?
Yeah, now it's okay.
Okay. So I would like to thank first all the organizers who have managed this event in this pandemic situation. And I would like to congratulate every member of Lucknow University for completing 100 years, and they are celebrating 100 years of that completion. With that, I will introduce about the facility map, what we have made for last 3 years, and we are maintaining, and we are going to have this portal for everyone. Each researcher can be part of that. So I will talk about this. We started this Indian Science Technology Engineering Facility Map in 2016 first, and in 17 it got attention of the government of India when I was working for INUP, Indian Nano Electronics User Program. I'm not sure how many people have heard. I have given lecture in Lucknow University in Material Science Division also about the INUP program and iSTEM when I started about it. So I visited there and I gave a talk about that time also. So this is a national portal which have the data of almost 20,000 equipment from all over the India. Already 20,000 equipments are there from 450 institutions. And currently more than 5,000 users are connected, and custodian institutions are also connected, where we have institute representative as well as the faculty member from different institutes. They are connected to this portal. So this portal is nothing but basically it is having the data of all the functional R&D equipment and facilities from government and private funding, whoever has established, have shared to this portal. It provides option to researcher to check the availability and operational status. Even you can see if people have updated the status of the equipment, whether it is up, down, or under repair. You can see in one search whether I should talk to this institute and this equipment is working or not. Even you can also know whether slot is available for me, which day it is available, what is the cost of that slot or particular equipment. In that way, you can get all the information through this portal. We are also coming with we have also come with the idea of having the expert on different domain. So those who are registering to this portal, they are marking themselves as an expert of different domain. And if someone want to have question, raise the question with them, there is a separate facility for contacting and discussing the particular topic through this portal. So you don't have to call anyone. You can just simple post the question, and the person who will be responsible for that domain expertise, they will find the notification through this portal. If they have some question, and they can answer through that. So we have also maintained the confidentiality of this question, so that your idea or whatever you want to discuss will not go in public. So those kind of things we have maintained in this iSTEM portal, and it really helped the researcher where there is no facility, first of all. And in that way, what we have got a mandate to is issued by Government of India to all the government bodies and institutions, as well as the CPSC, whatever facility they have developed or established through the public fund, they will have to list on this portal. What Madam was talking, we have to have separate portal for UP. I don't think that is the need. This is funded by the Government of India, and same facility, same portal can be used by everyone. I don't think any need is there for establishing another portal for this purpose, because this is also funded by central government. And here, each institution or each organization, whoever is there, can register, and they can share their facility. Their researcher can register to this portal. Apart from that, what government has mandated recently, that whatever technology or technology products are being developed in the institution level, or even it is commercialized, that should be part of the iSTEM portal. And this was approved by the cabinet in February 2020. Recently, we have got the 700 technology and technology product listed on our portal, which will give an idea to young researcher whether if they were trying to choose some kind of a research topic or some kind of they want research guidance, they can go through those kind of list, and they can see which area or which region, what kind of research work is going on. So that will really help the young researcher who are trying to make career in research. So with that, we have started this iSTEM portal. And we can see that more than 6 lakh visitors have visited this portal in last 4 months only. And this portal was launched by the Prime Minister, as it was considered one of the transformative idea by the Government of India and Modi government too. And it is chosen as it was chosen in 100-day program also, because it got completed this project in 100 days of portal development. With this, I would like to request all the researchers to register on the portal and get benefit of things what is listed in the facility. Apart from that, what we are trying to bring is the list of manufacturer and list of supplier. Currently, when you try to purchase any equipment, you will not get idea whether which equipment we should purchase, what accessories we should purchase. But what we are trying to connect, the people who have purchased the equipment in the past should be listed here, by which supplier it is provided, what kind of services they are getting, what is the performance of the equipment, so that you will get better idea before purchasing all those things. So with all those, we are bringing the supplier map as well as the service provider map also in the portal, so that everyone get proper benefit of those information, and the tool, whenever they need, they can contact easily through the portal and get tool up if it is down. Thank you, sir.
Thank you, sir, for a briefing, for the nice briefing. And I would like to acknowledge STEM for providing us with a nice platform of WebEx, so that we can organize such conferences of 1,000 people.
Yeah, I just want to add here, we have started this initiative for those people who are not having such kind of subscription. But eventually, anyone can request to iSTEM team for getting the login and password. We can provide whenever they want to conduct any webinar or conference event or meetings. One-to-one meeting can be also done through this WebEx platform. And we have got subscription for next 1 year. So if someone want to use that kind of things, this is available through iSTEM portal without any cost, because this is fully supported by Government of India. And I am trying to make use of that in proper way, what we have provided, what we have taken the subscription. So I am requesting everyone, if someone need, please register, request to us. Our email ID is there on the website, so that we can provide the login and this one, and you can register. You can get registered 1,000 participants at a time. Yeah, thank you, sir.
Thank you, sir. So now I would request our main presenter of the day, Dr. Ksenia Minakowa, to start with the presentation, and she will be speaking on the incident of Chronoville, and how the technology developed after that. And it will be a very nice presentation. So,
Wow. Oh, mm,
yeah, it's okay.
sorry.
Yeah, your screen is here.
Yeah.
I have some problems. Sorry. Mm. Do you see my screen?
Yeah, it has come. You start with the presentation.
Is it okay?
Yeah.
Mm, Okay, we will start. Hi everyone, good evening. My name is Dr. Ksenia Minakowa. I am an associate professor in physics department at National Technical University, Kharkiv Polytechnic Institute. We also celebrate this year, this not easy, not simple year, 135 years anniversary in our university, and also my department was established with the university at the same time, and we also have this little anniversary. Today I will speak about our educational motivational project, about why we start thinking about and why we start this project. Several years, maybe 10 years in Ukraine, we have a very big problem with scientists and engineers. Our children after school want to be work in medicine, in some economical profession, be work in law and so on. They don't want to be a scientist, be engineers, and we haven't enough qualified worker in this area. That's why we think about about possibility to use a well-known historical event as starting point for teaching various scientific and technical aspects. We try to show how using this now historical event we can teach any discipline, any science like chemistry, psychology, ecology, physics, or so on. And it was maybe March or May last year in 2019, and we I and my friends saw a HBO serial. It's called Chernobyl. It's about this disaster, and we think it's a good idea. Use Chernobyl to motivate children to study some not easy and some technical predicaments. It's also it is possible to liquidate in detail principles of work of nuclear power engineers, some scientific basis of processes that will took place during and after the accident. And we use this base as courses of physics, chemistry, and the other predicaments. It's also indicate for scientific discoveries and implementation, as well as engineering and technical solutions that were used during the elimination of the consequences of this accident. One man-made disaster allows us to disablement problem from the history of science and technology, physics, chemistry, ecology, engineering, energy, and so on. This approach allows to introduce the aspects of multidisciplinarity into learning. We don't need to use only chemistry or only physics, sorry, or only computer science, we should teach these predicaments one in each other. And the point of interconnection of different types sciences, which promotes a better understanding of needing of comprehensive development of school students, and motivate to study all natural sciences. Some information from Wikipedia about Chernobyl disaster. Chernobyl disaster in Wikipedia is man-made environmental and humanitarian catastrophe caused by two heat explosion and the subsequent destruction of the 4 unit of the Chernobyl nuclear power plant at night of April 26, 1986. The disease is considered to be the largest in the history of nuclear energy, both in the terms of the number of deaths and injured and a lot of economic losses. Our main mind was about Chernobyl, but besides, it's also a history explosion through scientific discoveries and real technical solutions, because a lot of scientists, a lot of people, engineers made all that they can to make this disaster not so hard and maybe it was it may be worse than it was. Chernobyl demonstrate what happens when the society stop paying enough attention to science, and what can happen if education goes into the background, if education will be not important for us. And we call our project In the Wake of Chernobyl. Our aim was motivation to study natural sciences, popularization, engineering, technical sciences, and specialities, preparing a new generation, our children, which is able to accept future challenges and create new safe technologies, not only in the energy sector, but also in all other areas. Now, this problem shows the possibility using well-known historical point as a start point for teaching different disciplines. We have several stages, and we will start this project every year. We will make this project every year from September until April, the date of the memory of Chernobyl disease. Preparing September and this, from September until December, we prepare teachers. We work with teachers. We explain them how to teach lessons and holding methodological meetings with teachers every week. Now that we make online. From January, we start school lessons in school and by university lecturers, by me and my colleagues, which is specialists in each, everyone in each area. With the end of the course on 26 April every year. Second stage, it's also we make the same lessons online for teachers not from my city, not from Kharkiv, from teachers from all Ukraine. And we finished like in anniversary the 2 months like competition for children and for the teachers. This is a list of our lessons. 2 lessons of nuclear physics, 1 lesson energy, 1 chemistry, 1 ecology, 1 of labor protection. We have this lesson in our schools. 1 lesson also like part of physics, alternative energy, and 1 lesson about history and current challenges. it's like a motivation lesson. On this slide shown our project founder. It's me, my colleagues Sergey and Roman. It was like an idea, and we think it was our man and rector on our university, Professor Sokol. He gave us chance and possibility to make this project real. Our teacher, our after of lessons, me, Professor Lazarenko, he speaks about energy, Professor Lavrova and Dr.Sinha school. This is our chemic specialist in chemistry. Dr. Shostopalov, he is specialist in ecology. Dr. Ilinskaya speak about labor protection. Dr. Zaitsev speak about alternative energy, and Dr. Radogos speak about history and about motivation. May I speak about one more time? We think the most important question, this is the possibility to solve problem, like if maybe we can think about maybe some, it's not maybe in future some another problem like Chernobyl, and we maybe it's not usual, but maybe we have some disaster and we have no clever with educational people who can decide and make this problem not so big. And that's why we need qualified specialists, engineers, technologists, developers who has knowledge based on math, physics, chemistry, and other natural and technical sciences. Every year, in Ukraine, the amount of such specialists is decreased. The same problem with the high school students who won't take exams in physics and chemistry because they scary physics, scary chemistry, scary math, and they choose history, they choose geography and so on, not choose natural sciences for their exams. And in Ukraine we have some system. If you your exams in school we use for university, and if you don't choose math, physics, you couldn't be engineer or scientist. Speak a little bit about history of Chernobyl disease. I hear my voice twice, but it's okay. Historical Chernobyl is a small town near Pripyat River in Kiev region. For most Ukrainians, the Chernobyl means what? I hear my voice twice. Sorry.
I think that's due to some low bandwidth at your side. Low internet bandwidth.
It's maybe something with internet, yes, connection.
You may continue with it.
It's okay, not?
তুই আসলে ব্যাক কিছু তুমি আছো তুই যে ব্যাক ওটা চেক করে ওটা ছকে ঢেকে আসার জন্য লাগে না তুই আসলে খুব
I hear all voices.
ভাই করে ওই ওই ঘরে বিছানায় থাকো কি আছে
I hear another voice, not mine.
The students are
Maybe I should start. It's okay. Do you hear me good or not? I can hear you. Maybe I should start.
Please continue.
Now you continue.
Where
Are
is
you muted on? Yes, you may
I
continue
can't
now.
hear.
You may continue now.
Yes, I start. Today, Chernobyl, the city has a status of population less, but it's not real. In Chernobyl lived about 3,000 people. Also, it has about 1,500 inhabitants every during all year, and about 1,500 come to Chernobyl for work. On September 1948, USA managed to generate electricity for the first time X-10 graphite reactor. In the same year, the suggestion by Professor Kurchatov, who accidentally also involved in the creation of the atomic bomb, began in the Soviet Union actively conducting research on controlled nuclear reaction to generate electricity. In May 1950, in the Kaluga region, construction first nuclear power plant in Obninsk. In June 26, 1954, the world's first nuclear power plant was launched. During the decade, several more nuclear power plants were built using two types of RBMK, high power channel reactor, and VVIR, full decision reactor. This usually preference was given to the first type. At the first glance, he seems best indicators this type of reactor used only in Soviet Union, and now this it was not a good experience, and it must use less more. In 1966, they decide to put into operation energy capacity of almost 12 million keV. They think about several places for this NPP, but at the last time they choose Kiev district and small town near Pripyat, river Pripyat. The Chernobyl nuclear power plant you see in the picture, first nuclear power plant in the Ukraine, and start built on September 1967. The last power unit, the power unit which were exploded after, finished in March 1958. 84, sorry. And the accident was on Unit 4 in April 26, 1986 at night at 1 o'clock during the decision test of one of security system. It was the test of system. The safety system provide mechanical engineer rotation of turbo generator which are stopped and generate electricity in this position of implosion of two emergency situation. One situation, complete loss of power supply of NPP, and another situation, the maximum decision basis accident, which in decision considered some as a rupture of large diameter pipeline in a reactor circuit. The project of this power supply is turned off, and electricity generated by turbo generator due as a result of rotation is supplied to start the pumps include cooling system of this reactor, and it would ensure guaranteed cooling of the reactor. And this reactor RBMK 1000 after the commission after this test has been conducted. And this test was have some problems, and there was a lot of factors about this problem. And after thermal power heating, about 0.7 gigawatt. Sorry, this is mistake. It was explode. The test begin early in the morning, and first was explosion, and after reactor was destroyed, and start fire, big fire with in the inside in the reactor. Our government didn't say anything to people who live near Chernobyl about this accident. They didn't say nothing about 3 days, and no one knows that it was explode and was accident. At the same time, measure when taken remove water from pool in the reactor. It was this water was radioactive, and it was a big problem because this pool it's near the river, and it was a big problem that the water in river also could be radioactive. Town Pripyat located about 3 kilometers from Chernobyl NPP, and they was all completely evacuated, and our government, no, Soviet Union government, decided to evacuate population from 30 kilometer zone near the Chernobyl power plant. All people couldn't take anything with any things, any clothes, any because all materials was radioactive. They lost everything, and it was like big problem. After this, government should think about building like a some sarcophag, some building up to unit 4, because they should shelter this unit from and destroy the unit to
website. Let's say if you want to link to website, you can also do
it was
that.
built in record time. This shelter
You can put up the recording
about
of your student if you are not trying.
200
We are
days.
using LMS for offline method, that the students will get some reference.
During the construction of this shelter, about 35,000 cubic meters of concentrate were laid, and 7 tons of metal constructors was installed. In addition to the construction, it was like install work of sphere near the unit 4. And and they finished in November 30 in Ukraine, in not in Soviet Union, in Ukraine, and in 2004, another government built new, most modern construction. It's look like, if you see this one, the hemisphere. This is sarcophag. Some people have don't afraid to speak about their memories about this tragedy, and you see some memories of these people who was the first in the Chernobyl and see this problem by his eyes. Total number in the first 2 years, about 240,000 people were liquidators, and total during the whole period, about 3 decades, it was about 600,000 people. Another memory, and one more. They speak about they buried completely 2 villages near this area, and it was made by soldiers who surrounded the village, affected the radiation. No one can have people who inhabited the liquidator village cried and watched with the difficulty of their things, their homes, and it all was distracted. It was awful. And soldiers destroyed all using tractors, excavators. They destroyed all and delayed all by this heavy technique. Last year, COVID year, I visited Chernobyl power plant with an excursion, and if I can show some modern photos by Chernobyl nuclear power plant photographer Dmitry. It's a not modern photo, and it's photo of it's building photo when built 4 unit of reactor, and this how look like reactor in our time. It's a sarcophag. It's built in 2004. This is a picture inside sarcophag, and another one look like a lot of. This is a strings of power plant. It's like nuclear, so it's uranium was. And this is a picture from horizon. It's also a picture in near explosion reactor. Workers which work in Chernobyl power plant can go to this reactor, to this area only for 5 minutes because there are big radiation. This is also this area with explosion reactor. Now we speak about nuclear physics, about what about nuclear decay, chain reaction. Becquerel was the first scientist who realized that some elements have natural radioactivity at the end of the 18th century. He observed blackening of the photographic film near the uranium compound. This was later due to uranium radiation. Unstable radioactivity in nuclear emit three main types of alpha, beta, and gamma radiation. Alpha radiation denoted as symbol alpha consists of helium nucleus with two neutrons and two protons. This is the most energetic, densely ionizing, but the least penetrating type of radiation. Alpha particles can stopped very easy by a sheet of paper. Also, they are not able to penetrate human skin. Alpha emitters can be very harmful if they enter to the body throughout the cut. Inhalation or food or eating food or water. Once in the body, alpha particle breaks down or releases energy, causing highly localized damage. For example, if any alpha emitter inhaled and reactive materials enter into the lungs, can absorb most of the radiation. Long-lived transuranic isotopes such as plutonium are also alpha emitters. Also, the same effect observed Pierre Curie and Maria Sklodowska-Curie, but for radium and polonium. Speak maybe quickly. Radioactivity first starts. This is the discovery of radium. This phenomena of spontaneous transformation of unstable nuclear into stable ones, accompanied of the emission of particles and energy radiation. All elements starting with number 83 in periodical Mendeleev table have radioactivity. Oh, sorry. So, nuclear reactions using reactor is a process of interaction of atomic nucleus with another nucleus or elementary particles, which combine by changing the composition of structure of the nucleus. Kinetic energy of new form particles can be much higher than the initial. We talk about release energy by a nuclear reaction. This is some example. You see on this slide. Nuclear reactor, nuclear power plant. In nuclear reactor, we have managed chain reaction. In explosion, we have unmanaged chain reaction. Managed chain reaction we can control and use for good things. First nuclear reactor in USA. This is a nuclear on the right picture, nuclear reactor in Obninsk in Russia. This is the control room, and you see on the this is the uranium on this picture. Sorry, and this is the reactor. This is the strings with uranium in this. You see down. This is the uranium strings. And this is the also this reactor, but he covered. Nuclear reactor, some advantage of NPP. Nuclear reactors do not consume oxygen and fossil fuels. It's very good for ecology. Do not pollute the environment with ash and harmful human products of fossil fuels. Also good for ecology. The biosphere is reliability protect from radioactive influence, and if NPP work good.
Yes,
I have 5 minutes. Sorry, I see a message. Maybe we
3 minutes
should
more. 3
stop.
minutes.
Have 5 minutes, yes?
Yeah.
I speak quickly. I try to. There's some pictures of the first about the helicopters, which try to make some deactivation. Maybe I should. One of the most big problem is the activation of because nuclear radioactive explosion. You couldn't. You should extinguish it without water. That's why Soviet Union chemists uses bags of sand, dolomite, and lead from helicopters. This is the structures into the reactor. So it's very it's not easy. It's very hard. You see ground. Also, you see pictures how it's not water. It's some chemical treatment. It's not water. It's they use water only for washing technique. Ecology. Some 5 myths about Chernobyl disaster. The first myth is that Chernobyl accident is the largest man-made disaster in the world. Not, but it was the largest nuclear man-made disaster in the world. Another myth about mutant animals growth in Chernobyl. It's not true. Another one that the nuclear power plants is very dangerous. No, it's dangerous if we have some problems and have non-control, non-manage or some problems. Another myth that Chernobyl is uninhabited. No, there are a lot of people and they live in Chernobyl and it's normal. The almost of people who live there, this is a worker of power plant because Chernobyl now is broken. It's stopped only 2 reactors. And another myth that alcohol protects from radiation. It's not true. In Chernobyl, now during 3 decades, ecology not so bad like before, and there are a lot of animals and leave their energy. We speak about atom energy has a huge potential, but we should use something else because we haven't enough reserves of coal, gas, and we should find something else to help with ecology and use renewable resources like wind, solar, water, hydro, or something else. And we have a scheme there, and we see that maybe after 3 decades, we have a lot of renewable, 62% of renewable energy resources. In my university, a lot of scientists, we make a lot about for sun energy using because sun surface has a big energy and a lot of energy come to our Earth. We have some developments of our scientists in this direction, solar collectors, and so this is our developments of our scientists. Some primitive way to passively use solar energy is a dark color water tank or more useful PVT systems like like these PVT systems. Main element collectors, vacuum tubes in black color. We can put on the surface also some thin solar elements, and it will be better for us. Time speak about maybe labor and about occupation. I try to show some pictures and say that now Ukraine work for nuclear power plants. Zaporizhzhia, Rivne, Khmelnytsky and South Ukraine, and they have capacity about 14 gigawatts for Ukrainian people. But now, after the Chernobyl disease, this disease gave us some opportunity to see problem, and international organization, World Association of Nuclear Power Plant Operators, established after this incident. Now every nuclear power plant have some center with full-scale simulation with mathematical modeling of processes with nuclear power plants, including emergency situation when operational personnel trained and tested. Every new nuclear power plant project and every staff in this project analyze and all accident scenarios and strategy to managing these accidents. The decision of nuclear power plant is also guided by the requirements of the state system to account and control nuclear materials and requirements and physical security. This is a laboratory with stress test, you see, and sorry, I finished. Future of our children is temporarily in our hands, but soon our future will be in their hands, and we should think about this problem and about accidents.
Thank you, Ksenia.
Okay, finished.
And I agree with you that the future of science is with the students. And since we are lacking in time, so I request our second speaker, Dr. Anadi Sinha, to start his presentation.
It's great to see you, Minakowa, here. Ksenia.
Great to see you too.
Dr. Punit Kumar, just one line I want to add before
Yes, sir. Yes, sir.
starts. Actually, I visited Kharkiv, the city where Dr. Ksenia Minakowa lives, and she took us to Turbo Atom Factory. And Amritesh is here, senior manager of the corporate Nuclear Power Corporation of India. And I shared back to Amritesh that the turbine was produced in Turbo Atom, which is there in the Kaga nuclear power plant in Karnataka. I think, Amritesh, I'm right, yes. Karnataka, Kaga power plant, nuclear power plant. So it was a unique experience to see such a huge factory producing turbines, and two of the turbines in Terry Dam and also in this Kaga nuclear power plant, they were supplied by the factory Turbo Atom in Kharkiv in Ukraine. So thank you, Ksenia, for showing us that factory. And it was great to hear a lot of things we never knew before. What you said today, that is still 4 nuclear power plants are running. And the last line before you said thank you was something really great, that the future of ours is really in the hand of the children we have. So it was great to listen to you. Thank you so much, Dr. Punit.
Thank you.
Inviting Ksenia.
Thank you. Thank you.
Yes, Dr. Sinha, please. Please unmute yourself. Dr. Sinha, you are muted. Please unmute yourself. Your voice is not coming. Please unmute yourself, sir. Please unmute.
That's okay, sir. Now it's okay.
Yes, sir.
First of all, very good evening to one and all present here in this program. And first of all, I would like to thank Dr. Anadi Srivastava, who is my colleague at NPCIL, who introduced me to Punit ji. And he is a person in NPCIL who is doing the same job, public awareness, by different means, by making movies, by editing the magazines, conducting lectures, so many things. He is also in this business actually. So I'm very thankful to Dr. Anadi Srivastava ji for this, and who introduced me, and I am very thankful to our Punit Kumar ji, Professor Punit Kumar ji, and the entire physics department and University Lucknow for giving me this opportunity to interact with all participants, students, faculties, and guests. So I'm very happy to see our respected Sri Pradeep Srivastava ji and our friend Meratra ji there in this program, who has organized several programs of mine in the Lucknow. So I'm again thankful to them. First of all, I really appreciate the physics department, really, because the topic they have chosen for this program is very close to my heart. I have service in NPCIL more than 36.5 years. And this topic, incidents of present, a solution to problem of the future. This I would like to tell you many very important things to one and all. Why it is so close to my heart? If you see last 100 years, 200 years, 300 years, last 50 years, whatever you Google, 99.9% accident in nuclear, space, aircraft, missiles, naval, factory, and laboratory, physics laboratory, chemistry laboratory, anything you imagine in the world, 99% mishappening, accident, incident has happened due to the human error. And I share with you one thing, that even our great Dr. Vikram Sarabhai's lab in Ahmedabad, they made a very big accident, and they lost a very costly equipment due to human error. And even our great missile man, he has mentioned Dr. Abdul Kalam ji in the Wings of Fire, that first missile was due to human error. So this topic is very close to me in the sense, technical things you can learn from several areas. But being a nuclear man, I know how costly it is. Costly means you might be knowing that Chernobyl accident has raised a question in continuing the nuclear power. Concorde plane, which is moving more than the sound speed, one accident has closed down the manufacturing of Concorde plane. So the topic is very close to me in the sense that consequences of this accident is very fatal, costly, and even as the continuing the same program is on the question. So what I would like to tell, that what we have missed in the centuries is the how to reduce the human error. So today I will cover 4 things. One thing that I will introduce, very small, this is brief lecture actually. You all are learned persons, all students are genius, I know. Already Professor Anuji has told me. So one thing, very first thing I'll share with you, that the introduction to Indian nuclear power program. I think how recently, 8th December, India made the world record 450 operating reactors in the world for continuous running of the reactor for 962 days. What are the secret? And one reactor is now going ahead at Canada. But our other reactors are also in the line. Narora reactor has crossed 850 days. So that is second thing. Third and important thing is that all this nuclear accident today we will be discussing is due to the human error. Maybe Chernobyl, maybe TMI, maybe Fukushima. So point which I will elaborate because it is not only related to the factory, not nuclear as I mentioned, it is also related to human life, your own life at office, at family, at your lab, everywhere. How you can take advantage of this program, how to reduce the human error. So fourth thing I will cover in this my program. And name I have given this maintenance strategy because if we are able to run the reactor continuously, it means our reactors are safe. So that's why I have given this topic. Now, I don't take much time. I have already discussed with you this. I will skip few slides. So time will be saved. This is our NPC. Now, this is the percentage contribution of energy in India. If you see very carefully, so nuclear is only 2%. But it is very, very important for the future program because as you know, there is no pollution, nothing in nuclear. Renewable energy is 20%, hydro is 13%, and oil gas is 8%, and you know, major chunk is coal, around 60%. So total installed capacity as on date is 3,74,000. It is now old figure. 3,44,000. It is now 3,74,000 in India installed capacity of energy. Now I just want to show you we are the third in the electricity generation in the world. If you see in billion units or trillion watt hour, in both units, if you see, is on the top, USA second, and India comes third. We fall in the third position. What is next slide is low per capita supply. If you see in India, Iceland, Norway, USA, France, China, far ahead. We are around now 1100 kilowatt hour in India. We are not able to meet the peak demand from this. Now, in India, the basic philosophy is that we should be away from the coal field. Where there is a coal field, the thermal power plant can be well established without much cost. And we are away from the coal field in India. These are the area where we are there. Very important data is for you, for the students. We have right now 21 power plants in operation. And one more plant will be added very soon. Already that has been made critical. That is first time in India, indigenous 700 megawatt plant at Kakrapara. So very soon it will become 22 power plant. And right now we have installed capacity nuclear 6780 megawatt, and it will add another 700. And 11 more are under construction in India, which will add 8100 megawatt to the grid. So this is the situation in India now. Now, as I mentioned, out of 450 nuclear power plants operating in the world, we have made this record 962 days. How we have achieved this? This secret I will share with you. 50 more plants are under construction in the world. So if you see percentage-wise, 450 reactors are adding 10% of the total energy in the world. And 50 more reactors, when it comes, it will become 15% of the total supply. This is the Kaiga Atomic Power Plant Unit 1, which has made the world. So basic principle is that mission vision alignment. We have mission safety first, production next. Here I would like to mention that our first reactor has started Tarapur 1 and 2 in 1969. And you will be very happy to know that more than 51 years of operation, successful operation. Recently, they have completed this November. So we have very strong safety record, excellent safety record, last 51 years. Nothing has happened to our plant. We see our mission. Mission is this, safety first, and vision is to reach our electricity each house in India. So we work on this. All employees are aligned to the mission vision of the NPCIL. Now, our principle is do job right first time. Do job right first time. There should not be rework in any area. So it is possible. It is possible by using error-free tools. Error-free tools means improvement in human performance for operation and maintenance. This I was talking about, how we can adopt these tools for our personal life also. Pokayoke is the another word used in Japan. In manufacturing, similar thing. They eliminate all product implications and mistakes. And how they do this, it is very important to know for our students. Very simple, innovative technique they use. One I will tell you. One factory in Japan was supplying soaps to the market. They got a report from the market. Many empty boxes are coming to the market. So they did the analysis Pokayoke. And one gentleman, labor, was very clever. He put a very powerful fan just before dispatching the box loading. And if box is empty, this fan, when they run, it will just go away. Only it is full of the soaps will stand and pass on. Very simple. So you have to see in your area also how you can innovatively think of the reducing error. I put this slide especially for you. This I definitely want our students to know. In any incident, just listen me carefully. Accident is very big thing. Any incident and any low-level event, we carry out the fishbone diagram analysis to establish the root cause of the problem. Once we know the root cause, then we eliminate those causes. It is not just replacing equipment, but we spend time to establish why this equipment has failed, why this incident has happened, and we do the root cause. For students, I heard from arts, science, all people are there. For students to perform well in the exam or competition, they should know 8 parameters and put on this fishbone diagram, like asking attitude, study techniques, utilization, persistent efforts, parent support, study materials, concentration. This is the biggest issue these days, and high aim. Like this, you put on fishbone diagram and the root cause why you are not able to perform the way you wanted and your university wanted from you. Very, very powerful tools. So this I will skip. Do your job right first time. Whatever you wanted to do, you do before taking the job in your hand. And for anything, you make a contingency plan. If you are working in the physics lab, you see if what can go wrong. You foresee the future problem. This should be at your hand. And this is very important for any accident, to avoid any accident anywhere. Contingency plan. This is my main slide, very close to my heart. Wherever you are working, wherever, This star principle you must remember. Star principle you must remember. This is a decision-making tool. Means anytime under you are under confusion, dilemma, or you are fighting with your boss, subordinates, or family members, just stop a few seconds. What you are going to do? Analyze either your action is right or wrong. Then you review whatever action you have taken, either it is in line with your thinking. This I will elaborate at the end actually. So this is the star principle, you please remember. And second thing is useful to everybody here. Of course, we use in our plant is three-way communication. This is, I'll tell you, the biggest mishappening in home, office, plant, anywhere. The communication gap. Communication gap. The biggest issue is once I tell something to others, I believe that it has been communicated, but that is not true. This is our assumptions. So three-way communication, what we do, once we send our technician to the plant, we explain them. You go and open 4315. Once they go inside the plant, he will telephone me. Sir, I have reached this 4315 pump. Is it right to open? Then I will tell, okay, you are absolutely right. Go ahead, open. Three-way communication you use in your office, your university, your family, there won't be any communication gap. This is very, very important thing. And even in home, in office, in lecture and laboratory, pre-job briefing, you must have some written procedure to brief them what you want expected. They are expected to do the job in lab or home or study. And just-in-time principle is very powerful in plant. It's everywhere applicable. Before a student goes for the exam, you just tell them just before entering that these are the mistakes we have done, our ancestor has done in the exam. Please take care. This type of things we also follow in our plant as a human reaction tool. This is our plant. We will not go into detail. You have learned a lot, Ksenia Minakowa, about the plant. So we have three types of plant here: pressurized heavy water reactor, of the reactor, and Tarapur 1-2 is BWR, boiling water reactor, and KK reactor at Kodukulam 1000 megawatt is LWR, light water reactor. Here only one thing I want to say you, that we have a practice of defense in depth. This fuel is safely placed inside a container. Then there are two barriers of the building, double containment, and then already coolant channel. Many things are there. So if one breaks, second will take care. Second breaks, third will take care. Third breaks, fourth will take care. Fourth breaks, fifth will take care. Even it is coming out of the building, then there are mitigation program to take care. Similar way. So that's why we are able to safely run our reactor. This is just to show you one of the our face of the reactor, where there is 306 tubes are there, pipes are there. That slide shows how difficult it is to conduct a maintenance job. Defense in depth, I am just skipping. As I told, we have a 5-layer of defense, and philosophy is to prevent accidents due to 5-layer of defense. Even it happens, so far not happen in our India. Mitigate their impact if they happen. We have enough backup program to mitigate them. And as I mentioned, always keep ready emergency plan. So we are also keeping this program intact. This keep. Now, one thing very important to know and to share with you, that 3 major accidents, nuclear accident has happened so far in the world. The first commercial reactor started in 1957 in USA. Research reactor started in Russia. Commercial reactor in USA. There, till date 2011, only 3 major accidents. Only I should not use. The nuclear accident happened so far. 3 Mile Island in USA on 20th March 1979. Chernobyl nuclear, as she has mentioned to you, 25th night of April 1986. Recently, 7 March 2011, Fukushima Daiichi nuclear power plant in Japan. So these are 3 accidents happened in nuclear field. And as I was mentioning, all 3 accidents occurred due to human error. This I will not going to elaborate you. And what happened in USA after TMI accident? Immediately they formed the INPO, Institute of Nuclear Power Operator in USA, Atlanta. They felt that it is time to promote highest level of safety and reliability in operation of nuclear power plants by imparting training to the operators. This was established in 1979, and the whole world was taking benefit out of this info. And there is a big body here, NMAC, which is of PPRI, Electric Power Research Institute. I was a steering committee member there to decide the maintenance strategy of the all reactors in the world. I was a steering committee member for 2 years. This is important as on date. After Chernobyl, question was raised either we should continue with or not. That time, entire utility of the world, entire body that is called WANO, World Association of Nuclear Operators, very active, very active. It formed on 15th May 89 after Chernobyl disaster, and mission is to exchange safety knowledge and operating experience among the operators of nuclear power plant. Here I will tell only one thing, then you will understand the importance of WANO. Anything happens, any reactor in the world, immediately send that incident, accident to all power plant in the world to cross check. Either you are safe on this point, and every plant will check this, that incident, and corrective measures are taken. Just one thing I just share with you. Fukushima, it was felt that standard core cooling system, core should always have water provision, even there is no supply. And that has been installed all over the world. And WANO body has visited not only plant headquarters and ensured that it is implemented. It means in case of Fukushima type accident where tsunami and earthquake came together, it can be managed now. So they have ensured this actually, peer review. So now coming to my main point, how we can eliminate human error reduction. This technique I will share with you. As I already mentioned you, that it is a set of work practice in home, office, plant to reduce the probability of human error. We cannot eliminate in toto. We cannot make it zero because it all depends upon the psychology of the human going for the job. That is very important. At that point of time, what is the psychology, mental condition, mental toughness of the person, that all decides. That's why I'll tell you, all accident in the past everywhere has happened due to the human error. And it is totally on that person who is on the seat. Recently, if you see last 10, 20 years, all accident of airplane has happened due to the error of pilot. There's no more point. So, but we should believe that people make mistakes. We also make mistakes day and night. But how to come out of the mistakes, which can lead to disaster? In event can be avoided by applying lesson learned. Whatever we learned from Chernobyl, whatever learned from the other offices, other plants, other incident, we should take full lesson and adopt those recommendations for our purpose. And error likely situation can be managed by identifying proper action. Now, we have enough experience in all fields, and know what kind of accident can happen. See, repetition of similar accident is taking place several places. So we know, so error likely situation can be managed by the applying the recommendation and lesson learned from our own mistakes, from mistakes of others. And one thing problematic, that we are not communicating to each other in plant, home, and office. Open communication should be established. Then only people will come out with the real cause. What went wrong, what mistake they did, unless until they get a full-fledged support from the management. And this machine interfacing, this is again applicable to plant, lab, and everywhere. A number of new machines are coming in everywhere. So the manpower has to understand this entire of the machine. Even in laboratory, suppose large number of new equipments are coming. Before touching the equipment, students should know in and out of the machine, and mostly safety features of the machine. So this is now human error. As I mentioned, I will just touch 1-2 points. That pre-job briefing, even in home, you are not briefing them, and you expect a result from your children, your students. Tell them clearly in writing what you want from them. Then after doing the job, you please post job review. See what blunder they did, what kind of things they missed, and adherence to procedure. Whatever job you are going to do in the lab, you have a procedure. See they are adhering to procedure or not. Some third-party checks would be there. I have already explained you three-way communication. JIT I have explained. Again, I put this because this is the heading. And self-appraisal, self-checking. Again, you see on the STAR principle, either you are capable of handling the situation or not. So this self-checking, self-appraisal is a big issue. But I will just tell you, this line, please see. Self-checking is a deliberate action intended to wake up a person's mind regarding the immediate situation. What is going to happen now? So self-checking before taking up any job, apply STAR principles. This I have already shared with you. And this again I will share with you. STAR principle. Stop means stop before performing a task. Think. Understand exactly what is to be done before you taking any action. I'll repeat, don't proceed in face of uncertainty anywhere. Please don't proceed. Stop there. Take advice from the seniors and others and analyze what will happen if I take this action. This you analyze, pros and cons. Then act. Perform the intended action. And review. Finally, review the outcome of your action and compare the actual outcome to the expected outcome. This is very important. This line, please note. Compare the actual outcome to the expected outcome. So this principle is very powerful for everybody to follow. And wherever I have given lecture, more than 500 lectures, everybody has taken this to their heart. And they are very happy. So it is also useful for personal life. Three-way communication I explained, but again I will tell you, listen. The senders initiate a message. I will tell something. They will listen it and understand. Receiver, acknowledge the message and tell back. Then again I will reply. Senders confirm the accuracy of the message. The receiver. Please note these 3 points. Three-way communication is not also easy unless until you understand this thing. And I will stop here. Thank you very much. If somebody wants to ask any question under the sun, I'll to reply you. Anything in the world, anything.
Thank you, sir, for such a nice speech, Prof. And I thank all the people who attended this webinar. Although there were some technical difficulties in coming online, but since this is a new software developed recently, so it will take time for us to be habitual with this software. But the software developed by the Indian authorities is a very good platform for us, and I think it will help us in near future. Because depending on the Chinese platform is creating some problems. So I think this Indian platform will be helpful for us. And I thank both the speakers, Ksenia Minakowa, for preparing such a nice talk and delivering it here. And at a very odd time, this must be your afternoon time, and on Sunday, it's a weekend. So you spend your weekend with us. And I am also thankful to Dr. Sinha for such a valuable remarks concerning the safety of the nuclear power stations. Because learning from one failure doesn't mean that you can stop research, you stop development. If there was an incident, so we should learn from it and develop new technologies, and that incident should not occur in future. All precautions should be taken. It doesn't mean that the development of the technology or the science should be stopped by one incident only. So in the last, we have shared the feedback link to on the chat, and I will also be sharing it on the WhatsApp groups, since there were some technical difficulties in attending it. So this time, I think it will be proper to facilitate everybody who was not able to join due to the problem of the software compatibility and all. So we will be also sharing the feedback link on the WhatsApp groups also. And thank you all for coming online and spending your time with us. And in the feedback form, we have also asked what kind of workshops do you expect from us in future. So please do remark on it so that we can organize workshops on those topics in the times to come. And thank you, Pradeep sir. Thank you, Amritesh, for being online. And thank you all for being here.
It was nice to hear Anadi Sinha Sahab, because I heard his lecture earlier before, but today was the nuclear to us. A very educated, received. I think fantastic. He was a key person in ensuring the safety of nuclear power plants in India. I think Senior would have been given you some idea to listen to Sinha Sahab, what he told about the safety of the nuclear power plants in India. Because he's the key person in the nuclear power plants. So I think Dr. Punit, it was great to have two experts, two belonging to very different, but with the same thought. And I think a lot of things, though I visited Ukraine, I was in her university in Ksenia, but I think I never heard a lecture on this topic. It was so important, sharing all the information. And then it was more treat to listen to Sinha Sahab, how Indian Nuclear Power Corporation is maintaining the safety. So thanks, Punit Kumar, for organizing such a fantastic people. And I think thank you for us. As rightly said by Dr.
So
after here, when I just leave the place where she lived.
So I am ending the meeting with thanks to Ksenia and Professor Sinha once again. Thank you all.
Thank you. Thank you for this
Minakowa.
chance.
Very good presentation, Minakowa.